So good morning once again. So for today's class, we are going to be looking at protocols and modules. Okay, and the topics what we'll be covering today, we'll look at an introduction to this whole thing, what protocols are. We'll touch on the TCP IP suite. We'll look at the OSI model, and then we'll end it up with encapsulation. Okay, so we see what they really are. Okay. Now, yesterday I remember telling you almost everything in IT is based on standards. Okay, and when it comes to networking, um, we basically rely a lot on models or on protocols. Okay, so what these models seek to do is they classify and set the structure for all our network protocols and standards. Okay, and these models are usually purported by various bodies or various organizations. Okay, now if you look in here, we have protocols. Now, when we say protocols, protocols are basically a set of rules that define how our network devices and software should basically work. And prior to today, I know we have basically encountered quite a couple of protocols. I think the very common one we spoke about was yesterday. We're dealing with cable, so we made mention of the Ethernet protocol. But in this course, we'll basically be dealing with a lot of protocols out there, some of which we can see here, like the FTP, we have BGP, we have the A02.1Q, we have EIGRP, RSTP, POP, SMTP. These are all various protocols that we would deal with. And I'm sure some of you might have probably heard of some already, right? So these are what we refer to as protocols. And if you clearly notice, most of these things are used for specific things, or they define how certain aspects of networking actually what takes place. Okay. But someone may ask, why do we even need these standards at all? Like, why the need for standardization? Okay. Now, if you look at what we have on our screen here, on one side, I have a couple of iMac um, computers. On the other end, I have a couple of HP computers. Now, for instance, if Apple decided to set up their own standards or their own communication protocol, what it means is all these iMacs will be able to communicate, right? Now, if HP decided to do same, all their PCs would be able to communicate fine, no problem. Okay. But then there's going to be a problem, which is in case any of these HP PCs want to actually communicate with these iMacs, it won't be possible. The reason being that they are all running what? Proprietary standards or proprietary protocols. That is why in IT, there's a need for standardization because we have so many vendors out there. And if there's no standard way of doing things, then everybody would be what? Doing what they like. Or I'll buy one device and it's not interoperable with the other device. So I'll go out there, it means in my stack, or if I enter my data center, everything has to be from what? A particular vendor, which is not going to help anybody. So to help us address these issues, we have some sets of standards or modules that we try to use. And a very common model, which I believe most of you might have heard of, is the OSI. Others might have heard of the TCP/IP model, right? So these are models that try to set the standards or define how networking actually takes place. So let's look at the first one, which is the OSI model. Now, the OSI model, this is the Open Systems Interconnections model. Now, when we say open, this tells you it is not proprietary, it's an open standard, right? Like everybody can use it, or it applies to every device or every vendor out there, right? So that's the full meaning, Open Systems Interconnection module. Now, this model tends to be a conceptual model, okay, that tries to classify and standardize the different functions in a network. So inside our network, we have so many different pieces of software, we have so many different pieces of hardware that actually we tend to use within our network. And the OSI model tries to make sure all these things can work together in unison. Now, this standard was created by the ISO, that's International Organization of what? Of Standards. They are the body that actually purported this particular standard. However, though we are not really using it in terms of the implementation of the protocols, okay, there's one thing you need to know. We have a model and then we have a protocol stack. Okay, so this is a model. Now, for most network engineers out there, we stick to the models to kind of let us understand how networking is done. The OSI model is divided into 7 layers. So far, we have spoken much about the physical layer where we were dealing with cables in the previous classes, where we looked at Ethernet, the UTP, and all of those things. Those kind of things operate actually within the what? The physical layer. So in this particular lecture, we are going to take our time and look at each layer, try and understand what it does, the function and the roles it plays within our network. All right. Okay, so you need all these layers to make sure your network can actually work properly. You don't just use one, but all of these layers are required for networks to actually work well. So let's start with the application layer. Let's try and know what it is and what we can use it for. Now, the application layer happens to be your closest layer to the end user. Okay, in as much as we say it serves as an interface between end user applications and the network. So anytime you have a software like your web browser, example, Google Chrome or Edge or Firefox or any of those things, and you open it up and probably you try to access a resource on a network, you are inviting what? The application layer, or you're interacting with the application layer. Note, it is not the software itself that makes the application layer, but rather the protocol that serves as an interface between what you are doing and the network. So for instance, I open up a browser and I visit a website like Nzuri Systems, and preceding that you see HTTPS or HTTP. This is what we call the application layer protocol. So it's that hypertext transfer protocol that is actually trying to connect you to the network. Right, so know the difference. Anytime we say application layer, we are not referring to the softwares in as much as we say it is closest to the end user, but they're not the set softwares you interact with, but rather the protocols that the softwares initiate. So like your HTTP, your all the other ones. One of your assignments would be for you to um, look out for a couple of application layer protocols for me. That would be an assignment for you to do. Right. I hope that is clear. Okay. So let's look at some of the functions which the application layer um, does or provides. Now, first of all, the application layer identifies communication with partners. Okay, so it tries to make sure it can communicate out there. Maybe it tries to communicate with another application sitting on a remote server or stuff like that. Now, also the application layer synchronizes what? Communications for you. It synchronizes communications between one end device to the other. Now, let's try and look at this diagram to kind of understand what goes on out there. Now, when you're dealing with the OSI model, usually the process starts on one layer and it goes down through the stack all the way to the other side. So let's take this stack you see here represents one PC. This other one represents another. So if we look here, it means we would have to transition through all the various what layers, right? From application, presentation, session, transport, network, data link, and then to what? The physical layer. Then that process is what we would call what? Encapsulation. Usually at every layer, an additional piece of information is added to the data in transit. And that process is called encapsulation. We'll actually look at encapsulation proper, but then for you to have a gist of it. As it moves and additional informations are added, that is what we'll call encapsulation. Now, after encapsulation happens, data is now sent to the other device. Now, when it gets there, a different process occurs, which we would call what? De-encapsulation, because now you start from the lowest layer all the way up, and the additional information that was added will be what? Stripped off that particular data. We would call that what? De-encapsulation. We'll talk much more of it when we tackle encapsulation on its own. Now, as you run around, or as all these layers interact with each other, we call it adjacent layer interactions. So you can see as these things go down and then they interact here, they are known as what? Adjacent layer interactions. But however, the communication that happens between the actual applications sitting on both machines is referred to as what? Same layer interaction. That is communication occurring there. So maybe I request for a web page, and the web server has finally been able to serve it out to my browser. That is what we would call that is what we will call the same layer interactions, right? Good. Now let's look at the next layer, which happens to be the presentation layer, right? Now the presentation layer, basically what it does is it formats layer, right? The presentation layer basically formats data. Please give me a minute. Hello. Morning. Yeah, fine. I was like, are you not joining the class? Yes. Okay. Yes. Okay. Awesome. Okay. So basically, what your presentation layer does for you is it formats data. Okay. So what we do is we have the native format of data, and then we have the standard format of data. So it is your job. It is the job of the presentation layer to make sure data is prepared properly to be sent through the remaining stack of data. Now, the native format of data is usually determined by the application which is used to create that data. So, for instance, I have a Word document, I have a PPT, I have a music like MP3, I have a video like MP4. That's the native format of data. But then when we talk about the standard form of data, that is where data actually has to be converted into what? Binary, things like bits, in a format that all the other devices in transit can actually what? Work with. Okay. So data needs to be translated in different formats to be sent over the network, right? So that's what it means, like converting your native format to the standard format. If not, it won't what go. Now, basically, why do I keep on repeating this thing? Okay. Fine. Yeah, sure. And apart from it's converting or translating data into various formats, it also does some amount of what? Encryption. So it adds some layer of security to data that is being what? Actually sent over the network. Because yes, we are doing things like that, but if you don't add any, so it adds a generic type of encryption to the data to make sure it stays same and nobody would equally what? Tamper with data. Now also it translates between different application layer what formats, right? So I think that's the major thing that it would basically do for you. Okay. Now let's look at the session layer. The session layer basically controls what? Dialogues or sessions between your hosts. So it's more like a time keeper. When I establish a connection from my PC to a server, I don't expect that connection to be infinity. There should be something that regulates the session so that when I'm done, it should be able to what, end it or stuff like that. You get it? So it controls dialogue between various hosts. So it establishes, it manages, it terminates connections between the local what applications. So for instance, if my web browser wants to communicate with or YouTube, for example, I don't expect that connection to be perpetual because there are so many countless number of people who are equally trying to access a video on YouTube. So it's the session layer's job to try as much as possible to monitor the connection and close it when it's done. If not, it's going to create an overload on your network. Right. Now, these three layers we have just spoken about, okay, as network administrators or network engineers, we don't usually work with these three layers. Okay, it doesn't really concern you so much. these layers are much more important to application developers, okay, because then they rely on the functions or things that go on in that particular layer to make sure the applications can work over a network. So it's not a layer that actually or actively has got much to do with network engineers. Though you're supposed to know they exist, you should know what happens in there. So when you have issues, it becomes easier for you to deal with. Now, the OSI model is not basically just purported for you to be a standard and make sure things work with each other. One of the major reasons why this model was purported is to make troubleshooting easy. So as a network engineer, if I understand what happens, or if I try to standardize or structurize my network operations, then when I have issues, it becomes easier to streamline it, because then I can easily say, oh, this is a layer 4 problem, maybe this and layer 3 problem. Okay, now this, it looks like the application is not working well, because I understand that the whole network process is actually divided or categorized into into layers, right? Are we good? Okay, sure. So now let's proceed and look at the transport layer. Right, let's look at the transport layer. Now, the transport layer actually segments and reassembles data for communication between end hosts. Okay, so as data sits on our PC as very large chunks of data. Like if I want to access a file like 1 gig, I can't send 1 gig in a single transfer. Get it? But that 1 gig has to be broken into into smaller segments. That way it becomes easier to send over the network. And one of the major benefits of that is, now if data is not broken into smaller chunks, if you try to send it over the network and there's an error, which means the whole thing would have to be sent again. But then because it is broken into chunks, you are likely able to live with some errors. I don't know those of you who have downloaded, there are some websites when you try to download a file, the moment there's an error, the whole thing corrupts. Like you can't continue from where you stopped. You have to download the whole thing again. But then on other sites where you use things like file downloaders, you realize you can pause and resume the download process. That's a similar thing to what your transport layer is doing for you. So I realize that there it tries to break up data into smaller segments to make sure that it can send it properly, and then also if there's a problem, it can be it doesn't create too much of an impact. For instance, if I'm watching a video on YouTube and I lose one of the segments, it will just pause for a while, but then afterwards it's going to resume play. Now, one of the other major functions of your OSI model is to provide logical host-to-host communication, right? So it tries to establish connections between your host logically. And it does that by relying on port numbers. We'll see port numbers as we go along the class, but then it does this logical host-to-host connection by relying actively on On port numbers. Then the very final thing, the major protocols that are found within your transport layer are the TCP and the UDP. That's the transmission control protocol and the user datagram protocol. Now, these two protocols have their own major characteristics. For instance, with your TCP protocol, this is a connection-oriented protocol, and we tend to call it a much more reliable protocol, because if it doesn't establish a connection, there's no way data is going to be sent. But with UDP is a connectionless protocol. So it's preferable, or is mostly used for real-time communications. So things like VoIP, like we are doing now. When you're doing VoIP, most of your communication is done using UDP, because that can afford some amount of Of losses. But then TCP does not afford losses. If there's a problem, the whole data has to be requested again. So for TCP to establish connections, it relies on something called the three-way handshake. Okay, so let's see a brief demo of how this basically works out.